Start off this way. In a circle, inside a circle, I've shown you guys three types of angles. Inside a circle, three types of angles. Those three types. 16, type 1. Central. What else do I have? Central. 3. Floater. And the other one? 23? Inscribe. Good job, everyone. Those three. Today, now the angle's going to be outside. All right, how do I find an angle that's found outside of a circle? Before I do that, another vocabulary term. I gave you guys tangent before break. Tangent. That's a line that hits how many spots? This is going to be 17. Tangent hits an exactly. Tangent line hits the circle in how many spots? A tangent. One spot only. Now I want to introduce to you a line that intersects in 2 spots. Anybody want to try to let that roll off the tongue? What are we, French? It's not secant, all right? It's secant, all right? Secant, everyone. Secant. Line that intersects 2 spots. So you got tangent in 1, secant in 2. So I want to go through each of my 3 diagrams here. How is the angle on the outside formed? Secant, tangent, one of each. You tell me. So angle B. How is angle B formed? It is formed by, where are those? 17 again. Let's go. 2 tangents. Good. That's formed by 2 tangents. Second diagram, angle A on the outside. How is that formed? That's a 24. My fire. 28.
A tangent and a secant.
There you go. Tangent and secant. And then finally, angle A on the third diagram. That angle on the outside is formed by 27. 17. Oh, we're 22.
By
2 secants. Good. 3 different ways to form an angle on the outside of a circle. Good news, only one way to find it. I don't care how the angle on the outside is formed. There's only one way to find it. Here you go. Angle outside circle. Outside the circle. There's only one way to find it. Guys, remember floater from before break? That was half of 2 arcs, and I did what to them? I added them. Angle on the outside, I subtract them. What do I subtract? I take the major arc and subtract it from the minor arc, and I'll get a little bit more detailed here with you in a second after you get that down. All right, so angle on the outside, I'm going to subtract the major from the minor and cut it in half. Where do you find this major and minor? It's what's in between the angles. I'm talking, when I say major and minor here in the formula, it's the arcs in between the angle, not on the outside, in between it. So you got a big decision to make right now. Who's got 25? 25. Hello, James. I got 3 diagrams up here. Just pick a diagram.
2 secants.
Okay, 2 secants. So how would I find angle A now? And again, I'm only picking one because it's the same thing for the other 2. I would take 1/2. What would I consider the major arc here? The major arc, now again, it means the arcs in between. So the major arc would be CE minus minor arc BD. All right, so is everyone clear on what I mean by minor and major? Okay. Questions? Ooh, well, there are 2 special type of angles we haven't talked about yet. We got inside and we had outside. What the heck is left, right? Oh, what is left? Here you go with the special type. And I know I don't have the 140 there. There we go. All right. So what happens if it's not inside? What type of angle am I talking about here? Look at angle BAC on your diagram right now. BAC. Is it inside? Angle BAC. Is it inside? Nah. How about outside? No, it's kind of like in between, isn't it? It's like a half and half. I call that a tweener. All right, that's a word I made up. Tweener. Between. Got it, Bridger? That's where origin comes from there. All right? Origin of the word. I call it a tweener because it's half inside, half outside. So how do I find a tweener angle? Depends on how it's formed. What's AC here? That's a AC. That's a tangent, and BA is a chord. So if it's a tweener angle formed with a chord and a tangent, I take half its arc. That's it. Take half its arc. So I take half of arc BCA there. Okay. So if it's a tweener angle formed by a chord and a tangent. Now look at the next one. I'm talking about angle BCD here. Definite tweener, right? Definite tweener. Just rolls off the lips good. It's fun to say. Definite tweener angle, but I don't take half its arc anymore. Here's why. How's this tweener angle formed? BC is still a chord. What's DCA? Secant. I don't take half an arc. I don't take half the arc if it's a tweener angle with a secant and a chord. I got bad news for you. The rule? I got none for you. There is no rule. What? But I'm still going to have you find it. And you're going to confidently find it. Just because you don't have a rule, how can I still find BCD? Look next door to it. What type of angle is right next door? Inscribed. You can find that one. And then what's the relationship between the inscribed and my tweener one up here? There you go. Okay, so there is no take half of this, add these two and take half of it. There is no rule for a tweener angle formed by a chord and a secant. All right? All right, now the fun starts. Let's apply everything. Bounce around the room, listening to you. Find CAB. Find CAB. 2. Who's got 2? Okay, I'm going to ask this same question to everybody today. These same set of questions. Here we go, Phoenix. BAC, is it inside the circle?
Yeah. Wait, what?
Angle CAB. Sorry, I went backwards. CAB, is it inside the circle, that angle?
No.
Nope. Is it outside?
Yeah. No, it's in between.
It's in between. It's a tweener. So we've at least identified I got a tweener. So what type of tweener is it? Back to you, Phoenix. What's BA called? Line segment BA. That's a chord, and CA is a?
Tangent.
Tangent. I got a rule for that tweener. That's half the arc measure. So I'm going to take half of 140, and you got yourself 70 degrees. So if you see yourself saying, hey, it's a tweener, what type is it? Secant and chord, or chord and secant, or chord and tangent? Next up, 2. Find minor arc AB. You're done. You're done. Stop talking, please. Okay. Yep. Our IQ all just went down a couple points. Too harsh? Too harsh? You're good? You're hard. Get out of here. You're not getting anything from me ever. All right, so if that's 160, please. Next one's got to be 20. Ooh, 20. That 20 I just labeled, or the 160 I gave you. Oh, this is pain. 21. Is that either angle inside?
Yeah.
Which one's inside?
Wait, say the question again?
Either. Okay, I'm just going to go from the 20, Dan. Just focus on the 20. Is that 20-degree angle inside the circle?
No.
Okay, is it outside?
No.
So it's a tweener.
Mm-hmm.
All right, what type? Let's see. What's line segment BA? That's a what?
That's our chord.
And what's CA?
That's tangent.
Yep. All right, so that must mean I took 1/2 its arc. So if I got an angle of 20, what do I do to the 20 to find the arc?
Oh, me?
Yeah, keep going here. You're riding this whole thing home here. Remember, I got that ready. I got 20 down by taking half the arc.
Okay.
And I need to go backwards now.
Okay.
So 20 was equal to half of arc BC or BA. So how do I go in reverse and if I had the angle, what do I do to it?
Double it?
Double it. Yeah, you can thank your group there.
Thank you.
40 degrees. All right. All right, next up. Number 3. 3. Here we go, Kyle. Ready? Angle X, inside or outside?
Outside.
We are done talking to each other. All right? Not to be funny, but if you said, where's the angle?
Outside.
Guys, there's only one way to find the angle on the outside. I don't care how it's formed, remember. If the angle's on the outside, I take half the major minus the minor. I don't care how it's formed. What's the major, Kyle? 90. Minor? 20. Done. Half of 70. That angle on the outside, 35 degrees. All right, now we got to step it up to the honors level. In number 4. Here we go. Woo! 14. Inside or outside? 38.
Outside.
Okay, discussion's over, right? 38 equals 1/2. I'll put the major there when I'm ready. Minus the minor arc. What did I label as the minor arc? X. What we're going to have difficulty is what the heck is the measure of that major arc now. This is where it becomes a little honors level. What do I plug in for the major? I know the minor's X, but what do I plug in for the major? Well, take a peek here. I just gave you 140 for that one. You know there's 360 in a circle. So how many degrees am I left over with now? I got 140. I know there's 360, so there's how many remaining? 220, but it's got to be shared between the major and the minor, right? Well, I just called that minor one X, and I know between them there's 220. So how can I write what my major arc's going to be here now? 18? 10?
220 plus X.
Okay, whoa. I got the 220, but if I add X to it, aren't I going over 220? And I know there's 220 between them, so it can't be more than 220. You want to adjust that? 220 minus X. You see, Zach, if I put plus, I'd have more than 220, which I know it's not. So there it is, 220 minus X for the major. Everyone all right on how we got there for the major? $220 minus 2x. You guys that weren't here on Friday, I do not like to distribute the 1/2. You can. I don't like doing that. Instead, I like to get rid of the 1/2 right away by multiplying both sides by 2. And be careful, again, when you multiply the right side by 2, that just eliminates the 2 and the 1/2. You do not touch anything inside the parentheses. 76 equals 220 minus 2x. Go ahead, let me know when you get for x. $23 when you're ready. 72, good work. Okay, we okay on that because you're going to use that same brand of thinking on number 5 now. All right, first question, where's the 60? 25, is 60 inside or outside?
Outside.
Outside. 60 equals 1/2. I'm going to subtract 2 arcs, and I already noticed that my minor one is X. How about the major now? This one, how do you write the major one now? All of this. Can you guys give me an expression to write that major one there? Oh boy, 3. Kyle, you're on fire today.
360 minus X.
There you go. You learn. Don't let lightning strike twice. 360 minus X. All good on how we got there? All right, go ahead, solve away. Seven, final here. $1.20. Thanks. All right, good job. And you're ready to go next level now. For you guys that were here on Friday, here's your first experience to some of this stuff. King size. And you know what I don't care about right now? A through F. Don't even look at it. Help me find all the arc measures first, if you can. If possible, find all the arc measurements before looking at all the multiple parts. All right. The one thing I see right away, arc AB is 150. So 150 degrees. I got a little diameter there, EOD. All right. Can we talk about this piece here? Why they gave us that? Because why am I going to stick two pieces are congruent without being important? All right, kids. Can I get a little help from you? Vocabulary help? What's AB in the circle? Line segment AB? Chord. Yeah. Yep. And how about line segment AD? Also a chord. All right. I believe it's been a while. If I know two chords in a circle are congruent, that means what else are congruent? If two chords are congruent, so are John?
Arcs.
They're arcs, yes. Everyone, if the chords are congruent, so are the arcs. So that tells me chord AB and chord AD, that means their arc AB and arc AD are congruent. So that gives us arc AD right now, right? A 150? Arc AD is $1.50 because the chords are equal. Facts are power. All right, I need more though. What about arc EA? What about arc BD? EB? I need every single arc up here. So let's start here. EA? EA? 30. Hey, diameters form semicircles, 180 degrees. So that means arc EA, 30 more degrees to get to 180. Let's see which one. Oh, now I can find EB. Arc EB? $1.20. They have to add up to 150, right? BD? 60? Why? Forms a semicircle. All right, everyone getting where we're... Look for semicircles. All right, look for semicircles. All right, we have every single arc now. We should be good if we know our rules. All right, that's half the battle. Know the arcs and know the rules. All right, let's start. Arc AD, you're welcome. We did it already. 150. Just watch how smooth this goes if we know our rules. Here we go. BAD. Who's up? Watch the same line of questioning. 23. Inside or outside?
Inside.
Inside. All right. So now I got 3 more questions. Central. Inscribed.
Yeah.
Done. I'm going to take half of what arc, Maddie?
BD.
BD, 60? See how, like, we already know it. It's not like, oh, I got to find BD now, and you got to go back and find the arc. You know it already. It's there. Nice and quick, 30 degrees. Some of you guys that weren't here before break, Friday before break, anytime I find a part of a multiple part question, I put it in the darn diagram because you never know. You may need it later on. All right, good deal. Let's go C. What do I got? ACD. $17, ACD, inside, outside. Who's got 17?
Oh.
Hi. Inside or outside?
Outside.
Outside? Discussion's over. Right? We talked today. If you're going to tell me an angle's outside, clear all on the outside. I'm going to subtract 2 arcs. You ready here, Riley?
Yeah.
I'm going to, oh, sorry, go ahead. I'm going to do the major.
150.
$1.50 minus the minor. 60. Got it. Oh, sorry. 45. Yeah. I don't want to take any of your spotlight. There's 45 degrees. Good work so far, everyone. Good work. How about EFB, everyone? EFB. Oh, boy, this is taking forever. 20. Inside or outside?
Oh,
Relax. It's where?
Inside.
Inside. Central.
No.
Inscribe.
No.
So that forward, it's got to be
Floater.
floater. We talk floater angles are found by adding two arcs and cutting it in half. What arc belongs to EFB? The one we're trying to find there, Bridger. Which arc belongs to that one?
120.
120. And I add that to its vertical angles arc, which measures
150.
150. Here we go. Everyone's good here? So I'm going to take half of 270.
135.
135. Look at everyone here. 135 right here. Oh, geez. E and F, huh? All right. Measure of angle EDF now. $14, inside or outside?
Inside.
ED, where is E? Did I say EDF? EDA, sorry. EDA, inside. Central.
No.
Inscribed.
Yeah.
So I'm going to take half its arc. What's its arc measure?
30.
30. There we go. These can be brutally painful if I don't know my rule, or not bad if I know my rules. And finally, F. Who going to need a stud for this one? EDC. Here we go. Who's got 21? Here we go, Dan. You got this. I believe in you. Okay, look at. Do you see EDC, Dan?
Yeah.
Okay. Is it inside the circle?
Yeah. No.
Good. Good. Is it outside?
No. It's a tweener.
Darn right it is. All right. Let's see how this tweener's formed. What's CD, Dan?
Oh, that's a tangent.
Okay, so half of it's a tangent. The other part, EOD, is a what?
Diameter.
Okay, which we also is a chord, right?
Mhm.
All right, so we just went over today. If it's a tweener angle formed by a chord and a tangent, how do I find it? Chord and a tangent.
1/2 the arc.
Okay, ready? So I'm going to take 1/2 the arc that's in between it. Let me highlight it for you. Here is the arc that is in between that angle. E to B to D. What type of arc is that?
Major arc.
It is, and
Semi.
semicircle. What's it measure?
180.
So you're telling me to take half of,
180.
which is?
90.
Yep. And is anybody just getting real? Oh, well, why couldn't I? Well, actually, it's just half of 180. Sorry, I'm getting ahead of myself. Just trying to mimic one of you guys. Anybody saying, well, why are you doing it that way? Isn't it just a radius drawn to a point of tangency? Yep, it is. So you could do it that way too. Forms a right angle. All right? All right, you guys in your group right now have that final one. Let's see what you can do with this final one before I let you go. Angle P, inside or outside? All right, you know how to find it. No discussion. See you, Zach. Keep it real. Behave. So I know it's something minus 56, because 56 is the minor there.
Say, bro. I thought I did something wrong first. It's only 8.
Oh boy. 7. I know the minor arc was 56. How'd you find the major? EKL is a diameter. Good. And what'd you get for the minor? 124. Yeah. There we go. That's how I found the major there. So angle P, how many degrees? Finish this day off right. 26. Take your time, Will.
I don't think I did this right.
Why don't you think you did it right? What's getting at you?
I ended up with 12.
Did you have your major as 124 and your minor as 56? All right, okay, let's go back. 124. Are you okay on how I got that as 124? Because that's a diameter. Semicircle, yep.
34.
All right, good work. Good work. I think that's a good time to end it here. And hey, this is on everything now. Right, this is all types of angles that you're about to go on your assignment here. All types of angles here.